All right, chapter 4:6 again deals with isosceles, equilateral, and right triangles. Please be sure you copied your cuts. All right, to begin, an isosceles, let's recall what it is. That's the triangle that's going to have the two sides, or at least two sides that are congruent. Okay, but on an isosceles triangle, what we're going to look at here is that the non-congruent legs of an isosceles triangle are called what? If we remember, if these two sides are the congruent sides on an isosceles, the non-congruent side is called the base, or the base leg. So here's our base. These are our two congruent. There's the first congruent leg, and then there's the second. We can tell that by the green markers. And the side that is not congruent is called your base. The two angles adjacent to the base are called the base angles. So here's my base leg. The two angles on the corner of a base leg are called base angles. Right? Again, the angles connected or adjacent to our base leg is called the base angle. Okay? And then the vertex that's opposite or across, in other words, the base leg, is called the vertex angle. This leg here, again, base leg, the angle opposite is called your vertex angle. Here's our theorems. Theorem 4:6, base angle theorem. Remember, we don't need to remember the theorem 4:6. We don't need to remember the number, but remember the name. Base angle theorem. If you have an isosceles triangle, such that I have here, triangle ABC, okay, and I can quickly point out the base leg because I see that AC and AB are the congruent legs, therefore automatically making this my base leg. Okay, so here are my two congruent legs, meaning BC is my base leg, it's the one that's not congruent, and A is going to be my vertex angle. Okay? Now, here's the theorem about 4:6, the base angle theorem. If two sides of a triangle are congruent, as in AC and AB, then the angles opposite them are congruent. So in other words, the base angles, angle B and angle C, will be congruent to one another. That's why I have the same marker. Base angles are congruent. All right? So here again, that means that I have here side length AC. AC is congruent to AB. Let me do that this way. AB is congruent to AC. Then that means that angles B and angle C are congruent. Okay? Another way to look at that, instead of looking at base angles, the base leg, and talking about their base angles being congruent, another way to see this is on an isosceles triangle. You know you have two congruent legs. Well, the angle that's opposite to one of the congruent legs, which AC, the opposite angle is B, okay? And then the other congruent leg is AB, its opposite angle is C. The two opposite angles are going to be congruent. All right, but if you understood it when I said base angles, fine, work with that. Right, and let's continue on. Theorem 4:7 is the converse to the base angles, okay? Remember if-then statements, the converse, the conditional, okay? That means that if two angles, I've switched it, of a triangle are congruent. If two angles of a triangle are congruent, that means angle B and angle C are congruent, then that means that the sides opposite them will be congruent. So angle B and C are congruent. That automatically means that the two sides opposite them will be congruent. Well, the question is, if angle B is congruent to angle C, what's the leg opposite to angle B? It's AC. Okay, that means AC is automatically going to be congruent to the side that's opposite to angle C, because angle C is congruent to B. The side opposite will be congruent. That's AB, and it's congruent to AC, because opposite sides of an angle The two angles that are congruent will also mean that the two sides will be congruent. All right, and I've drawn that down here. Just again, I see that my two angles are congruent, angles B and C, and because I know that angles, just looking at the angles, the two angles are congruent, that automatically means that the sides opposite to them will be congruent. So the side opposite to angle B is AC, and it's going to be congruent to the side opposite to angle C, which is the AB. And here's that written. Angle B is congruent to angle C, then that means that the side opposite to angle B, which is going to be our, I should have done it the other way. Angle B is going to be AC. I should have switched this around and say AC is congruent to AB. Right? Know that, here's the next information, equilateral triangles, they are special type of isosceles triangles. Remember, isosceles means at least two congruent sides. Well, equilateral has three, and isosceles means at least two. That means that an equilateral is a special type of isosceles. The corollary, I love saying this word here, will state that a triangle is equilateral if and only if it is equiangular. Okay? The corollary, try saying that fast, for Theorem 4:6 is if a triangle is equilateral, then it automatically means that it's equiangular. So if it's equilateral, it'll be equiangular. Okay, and the reverse of that is 4:7. Okay, if it's equiangular, then it's equilateral. Okay, the flip. Triangle ABC, if it's equiangular, then it's going to be equilateral. If it's equilateral, then it's going to be equiangular. Right? And finally, what we have here is the hypotenuse leg theorem, which is quite simple. Okay? The hypotenuse leg theorem is Theorem 4:8. It's a congruence theorem, and all it deals with is right triangles. So I have two right triangles, triangle ABC, and I'm trying to say that it's congruent to triangle DEF. Now, on the hypotenuse leg, that's saying that if the hypotenuse on a right triangle, and the key word is right triangle, are congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. So first of all, both of the triangles, if I'm using the hypotenuse leg theorem, if I'm using that particular theorem, hypotenuse leg, that means I'm automatically talking about right triangles. And if that's the case on a hypotenuse leg, that means the key word in that theorem is hypotenuse. It means you need to include the hypotenuse. So the hypotenuse is opposite to the right angle B here. So you automatically have to use the hypotenuse, which is AC, and you just pick another leg. Let's say it's BC. If these two legs, AC and BC, are congruent to two other legs on another right triangle, that automatically means that the two triangles will be congruent. So, my hypotenuse is AC. It appears that it is congruent to triangle DEF. It's congruent to DF. And then the one leg that I use here is BC, and because it has the one marker here, and it has one marker on EF, because I use a hypotenuse and the leg on one triangle, and it's exactly congruent to the hypotenuse leg on the second right triangle, then that means that the two triangles will be congruent, okay? Because BC is congruent to EF, which is just a leg. These are legs. And AC and DF are congruent, which is your hypotenuse. We must use that hypotenuse. Then that automatically means that triangle ABC is congruent to triangle DEF. Okay? Now, I didn't have to use BC or EF. I could have used, come on. I could have used AC and AB. And I could have used DF and DE. It's still hypotenuse leg. It doesn't matter which leg you use. It's still hypotenuse leg that are congruent to one another. What you cannot do is this. What you cannot do is say, let's delete this here and delete this here. What I cannot do is say AB on this triangle is congruent to AB, and I'm going to take this out here. Alright, so let me back up. What I cannot do is say the following. AB is congruent to DE, and then BC is congruent to EF. The theorem for hypotenuse leg, again, key word is hypotenuse. I didn't use the hypotenuse on these right triangles. Therefore, this does not mean that they are going to be necessarily congruent. But I see something that can override that. I see side angle side. Okay, so and that would be that theorem instead of hypotenuse leg. This would be side angle side instead. Okay, but again, for hypotenuse leg, if you're proving it by that, you must use the hypotenuse and one of the legs. So here we have this here. Okay, and that's 4, 6.